Hello everyone, welcome to Code Meal. So in this video, we are going to solve one of the most popular questions from the Leetcode. So the question name is 2sum. So it is a very fast question from the Leetcode problem section and also it is an easy question too. So without wasting time, let's look into the question. Given an array of integers, nums and an integer target, return indices of the two numbers such that they add up to target. So which means we have one array which is a collection of integer and one more integer value which is a target. So using these two inputs, we have to find the two numbers from the given array and the sum of those two numbers should be exactly equal to the given target value. And finally, we have to return the indices of those two numbers. So this is what exactly we have to solve in this problem. So along with the question, they have given us a few more notes as well. So those are each input would have exactly one solution. You may not use the same element twice and we can return the answer in any order. So here we don't need to worry about the no solution concept because we are guaranteed that all the problem will have exactly one solution. And mind this point while you are solving this question because we cannot use the same element twice. And one more thing, we can return the answer in any order. So order doesn't matter. So I hope this question is clear to you. If it is not clear, wait, I will explain with the example test case. Then you will understand. Let's move to the example. So in the input, we have one nums array and a target value which is 9. So here what we have to figure out is we can choose any two numbers from the given array and we have to check the sum of those two numbers if it is equal to target value or not. If it is equal, we can return the index of those two numbers. So if you look at this example, you can easily identify that number 2 and number 7 can be easily added up to target 9 and the index of those two numbers is 0 and 1. So that's what they explained here also. And the example 2 and 3 are same as the example 1. So I'm not going to explain it again. So you can check these two examples at your practice time. So let's move to the next step. So before start writing the code for the question, we have to come up with the algorithm first, or you may call it as solving steps. Because if you directly start writing the code for this question, you will get stuck in between. And that solution may not be the optimized one. So to avoid these kind of situation, we should always come up with the algorithm first. Then only write a code according to the algorithm. So always keep a practice that we have to come up with the algorithm first, then start writing the code. And for this question also, we are going to follow the same thing. So let's move to the algorithm. I took inputs from the example 1 for the explanation purpose. You can take any other example also, that is your choice. So for this question, think about what are the possible solutions can be there. Definitely there will be a multiple solution. Don't worry about that. Think about any one solution which is coming to your mind when you're looking at this question. I will tell you. We can create a combination of all the two numbers from this array and calculate the sum of those two numbers and compare the sum with the target value. If it is matches, we can return the answer. So that's what comes to everyone's mind. I know that is perfectly fine because we have some better approaches for this question. So before moving into the better approach, let's deep dive into this approach and figure out what is wrong with this approach and what kind of improvement we can do to this approach. Okay, so for this approach, we have to create a combination with two numbers for all the values in the given array. Okay, first we'll take a number 2. So we can combine with all other three numbers and create a combination of two numbers. So the combination will be 2 and 7, 2 and 11, 2 and 15. So this is the first set of combination. So let's take next number. So 7. So the combination will be 7 and 11, 7 and 15. If you notice that I didn't create a combination with number 2. Why? Because the combination of number 2 and 7 is already there as part of number 2. We don't have to create a duplicate combination again. So we can simply ignore that combination. So which means while creating a combination, we have to consider the numbers only which are next to that number, not previous to it. Okay. So the next number is 11. So for the number 11, we have to consider only 15. So the combination will be 11 and 15. And for the number 15, we don't need to create any combination because the number 15 is already included in all other combinations. If you keenly notice that 15 and 2 is already there, 15 and 7 is already there, 15 and 11 is already there. So we don't have to create a duplicate combination. We can simply ignore this number. Okay, so as part of this approach, we created all the possible combination as a first step. Okay, so what is the next step? We have to calculate the sum of the each pair. So the sum will be, so for this 9, for this 13, 17, 18, 22 and 26. Okay, we calculate the sum also. What is the next step? We have to compare the each sum value with the target value. If it is matches, we can return that particular pair. Not the particular value, we have to return the index of those pair. I hope it is clear. So we can take this value and compare with the target 9. Yeah, it is matching with the target value. Number 9 matches with the target value 9. So what we can do here, we can simply return the index of the number 2 and number 7. And we don't have to check the all other sum value, because what they mentioned in the question, there will be exactly one solution for one question. So if we found any one solution, we can stop right over there. We can return the index of those two numbers. We don't have to check the all other pairs. So the answer will be 0 and 1. Okay, we found a solution, we created an algorithm, we can start writing code for this algorithm. But can we solve this question with some other better approach? Yes, definitely we can. So to find that, what we have to do? We have to analyze the complexity of our current approach. Then only we come to know that what kind of improvement we need to this approach. I hope everybody knows about the time and space complexity, using which we are going to analyze the efficiency of this approach. So what are all the steps we followed in this approach? We took all the numbers from the array and created a combination with all other numbers. So if you take number 2, using that we created a combination with all other 3 numbers. So the first step is to check all the values from the given array. So to check all the values, what will be the time complexity? It will be O of n, linear time complexity. Because if the array sizes increases, our checking count operation also will increases. So the time complexity will be definitely O of n. So this is for checking each number from the given array. To create a combination, we have to again check the other numbers as well. So for the number 2, we checked all other 3 numbers. So to check the all other numbers, what will be the time complexity? It will be O of n minus 1, because we are not checking the same number again. Because they mentioned in the question that we should not use the same element twice. So that's why we ignored the number 2 while creating a combination for the number 2. So if the time complexity for checking all the values is O of n, then what will be the time complexity for checking all the values except one value? That will be O of n minus 1. Okay, but there is no standard time complexity with the O of n minus 1. So we have to consider this also as O of n. I hope you guys already know about this. So I am taking this as a O of n. So this is for checking each element in the given array, and this is for creating a combination with all other elements. Okay, so what will be the final time complexity? So n into n square. So it will be O of n square. So the final time complexity of our current approach is O of n square. Can we improve this time complexity by choosing any other better approach? Yes, definitely. But why do we have to go for other approaches? I will tell you. Go to the question again. If you go down, there is one follow-up. Can you come up with an algorithm that is less than O of n square time complexity? So we have to come up with a solution whose complexity is less than the O of n square. But our current solution time complexity is O of n square. Can we come up with another better algorithm? Yes, we can. Okay, I will remove these things for explaining the other approach. So when I say other approach or a better approach, what can be improved? Think about that. Either we can improve the time complexity or space complexity. But in this question, they have clearly mentioned that we have to improve the time complexity. So to improve the time complexity, what we have to do? We have to reduce the number of operations. So how we can do that? Let's take the first approach. What we did? We checked all the number twice and created a combination. Because when I take number 2, I have to check all the other numbers to create a combination. This is like we are checking each number twice. So we have to avoid this approach and come up with some other better approach. Which means we have to check each number only once rather than checking it twice. So this is what we have to do. So then only we can reduce the number of operation and improve the time complexity also. So how we can achieve that? I will tell you. So let's take the first number. So number 2. So I'm taking the number 2. So for the number 2, which number can be added to this number and the total sum will be equal to the given target? Definitely we know we can add number 7 and we can make the sum of target value. How do we know that? Everyone knows about the subtraction in the max. So you would have subtracted the value 2 from the target value. So 9 minus 2, 7. So that's how you will come up with the value of 7. So from this logic, what we can notice is when I am checking the number 2, if there is any other number with a value of 7, then I can easily create a combination for those two numbers and match with the target value. So in simple terms, when I check every number for the first time, I'm going to maintain a difference value from target in some place, which means let's take number 2. So what is the difference of number 2 from the number 9? The difference will be number 7. So I'm going to maintain this difference value 7 in some place. Let's take one array or list. I'm going to maintain one list. So in that list, I'm going to maintain the difference for each number in the array. So when I take number 2, the difference will be 7. So I'm storing it in the list. So when I check the next element, so it is 7. So before finding the difference, I'm going to check that whether this 7 is already present in the list or not. If it is already present, I come to know that somewhere in the array previous to this number 7, I found a number 2. That's why the difference value 7 is stored here. I hope this is clear to you. So what I'm doing here, so when I check any number, I'm going to maintain the difference of that value from the target in some place. So that some place is this list. So what is the difference for the number 2 and number 9? That will be 7. Okay. So coming to the next value. So I have to find the difference between 7 and 9. So before doing that, I'm going to check this value whether that number is already present in the our maintained list or not. If it is already present, our solution pair is ready, we can directly return the index. Let's take another example. So here I am changing the target value to 18. So empty the list, and first I will do, I will check the number 2. Okay, I am checking the number 2. So for the each number, what I have to do, I have to find the difference. But before finding the difference, what I have to do, I have to check whether the number is already present in the list or not. So the number 2 is not in the list. So what I have to do, I have to find the difference. So 18 minus 2 equal to 16. So I'm going to store this 16 in the list. Okay. So move to the next number. So 7. So do the same process. Check whether this number 7 is already there in the list or not. It is not there. So what I have to do, find the difference. So 18 minus 7, which is equal to 11. So I'm going to store the 11 in the list. So move to the next one. So 11. Do the same process. Check if the 11 is already there in the list or not. Yes, it is there. If it is there, what we can decide? Somewhere in the array previous to this number, we found a number 7. That's why the difference value of 11 is stored in this list. So we can conclude that we can create a pair of number 11 and the number which created a difference value of 11. That is absolutely number 7. So that's why we store the number 11 here. So I hope this algorithm makes sense to you. You don't have any confusion. So using this logic, we have to check the each number only once and we can create a pair whose sum is equal to the target. And you know how we calculated the difference and created a sum. But in the final solution, we have to return the index, not the value. If it is a value, that will be very simple. While checking the number 11, we can directly return 11, 7. Because somewhere in the array we found number 7, that's why we stored 11 in the our new list. So while checking the number 11, we can come to know that number 7 is already there and we can create a pair with the particular number and return the answer. But in our case, we have to return the index of those numbers. So to return the index of the number, what we can do? While storing the difference in the list, we can store the index also along with that. Which means, so let's take this list. Okay, I am checking number 2. What is the difference? 16. So I'm going to store the 16 along with the index. So I'm going to create a nested list like this. So for the number 7, that will be difference is 11 and the index is 1. So like this, for the each number, I'm going to store a nested list in the newly created list. So in that way, we can easily identify that which two numbers create a pair and index of those numbers. Which means, while coming to the number 11, we can check that whether the number 11 is already there in the list or not. Yes, it is there. But how did this 11 get stored here? Because of number 7 is already there in the array. But where the number 7 is located? In the index 1. So that's what we stored here. So what we can do? We can take this index and index of our current value. The current value is 2. So 1 and 2 makes our final sum pair, which is equal to the target value 18. So I hope you understand this. But here one drawback is, while checking whether the number is already present in the list or not, we have to iterate through the entire list. Then only we can come to know that whether that particular number is already present in the list or not. So to check the entire list, the time complexity will be again O of n. Then the final complexity will be again come to O of n square. Then there is no use of creating another algorithm. We can use the previous algorithm, which also has same time complexity. But we can improve this checking operation by using some other data structure or some other collection. So to check the value in the collection, if it is exist or not, which collection will give you better performance? Absolutely, we know dictionary. So dictionary is nothing but we can store the values in the key value format. So in the dictionary, if you want to check our value exist or not, the time complexity will be O of 1, which means constant runtime. So instead of storing the difference and the index in the nested list, we can use the dictionary collection, which will give you a better performance. So the same thing I'm going to do in the dictionary. That's it. So instead of taking the list, I'm going to use one dictionary. So the same operation I'm going to do again. So first I will check this number 2. If it is already there in the dictionary, I can return the final answer. If it is not there, what I have to do? I have to store the difference. So the difference will be 16, which is key, and the value will be index of the current value. So 0. So going to the next value 7, check whether the 7 is already there in the dictionary or not. It is not there. What I have to do? I have to find the difference. Difference will be 11. So the key value will be 11 is to index of this 7. So 1. Okay. So the next value 11. So the 11 is already there in the dictionary. What I have to do? I have to take the index of the current value. The index will be 2. 2 and this 1 I can take, because this is the index where the number 7 is located. So that's why we stored 11 is to 1. So while checking the number 7, we stored the key value of 11 is to 1. The 11 is the difference. 1 is the index of the particular number, not the index of the difference value. I hope it is clear to you. So this way we can improve the performance and also reduce the number of operation and improve the time complexity also. So this entire algorithm is called as hash map. The another name of dictionary is hash map. So using dictionary only we are achieving the optimized solution. So this entire algorithm is called as hash map. So this way our time complexity is improved to O of n, which is linear runtime, because we are going to check the each number only once from the given array. So the time complexity will be O of n. To check the number whether that is present in the dictionary or not, that will be O of 1. That is constant runtime. We can ignore that. If it is a constant time, we don't need to consider that time complexity in our final complexity. We can simply ignore that. So our final complexity will be O of n. So finally we have improved our algorithm and we can choose this algorithm for our final solution. So let's write a code using this algorithm. So the first step what we have to do, we have to create a dictionary. So I'm going to name the dictionary as D. So D equal to one empty dictionary. So what's the next thing? We have to check the each number in the given array. To check that, I'm using for loop. So for I in range, len of nums, we can take the direct number from the array also. But if we are doing that, we cannot find the index of that number. So which means we can directly take number for element in nums. So this way we can access all the elements from the given array. But if we are doing that, how do we know that for this particular element what is the index? Because we need to store the index in the dictionary. Then only we can return the final answer. So instead of doing this, I am taking this for loop for I in range. So this range function will start from 0 and ends with the whatever value I provided here. So then len of nums will be whatever the array size I am passing to the range function. So it will take the values from the starting index to ending index. Okay, this I means index. So first step what I have to do, I have to check whether the particular value is already there in the dictionary or not. How to get the value? So value equal to nums of I. We can access the any value of the array using index, because we already know that this I is representing index of the particular array. So we can pass the index to the particular array, we can take the value. So I'm taking the first value. Then what I have to do, I have to check whether that particular value is already there in the dictionary or not. If value in D, if the value is already in the dictionary, what I can do, I can directly return current index. This is current, I is the current index. What is the index of the another value? We can take it from the dictionary. So D of value, which mean here let's say I reached to number 11. I am checking whether number is already there in the dictionary or not. Yes, number 11 is already there. So what I am doing, I am returning value of number 2, which is current index value 2, and I have to take the 1 from the dictionary. So what I can do, I can access the any value from the dictionary using the respective key. So the key will be current value. So dictionary of 11 will be 1. So I am taking that 1 value. So I am returning the final answer. So that's what I'm doing here. So I hope you understand this. So what if the value is not in the dictionary? We have to find the difference. So difference equal to target minus value. If it is there, we can directly return the answer. If it is not there, we have to find the difference and we have to store the difference in the dictionary along with the index. So what I'm doing, storing the difference in the dictionary along with the index. So the value will be 11 is to 1. I'm storing. That's all. Our entire solution is completed. So this is what I explained in the algorithm also. The same step I converted into Python code. I will explain the code one more time. So what I'm doing, I'm creating an empty dictionary to maintain the difference and the index value. Then I'm checking the each element from the given array. For the each value, I need the index also. So that's why I'm using the range function. and I'm considering this I as a index value. So for the each index, I'm taking the value, and if the value is already there in the dictionary, I'm returning the direct answer, which is current index and the index of the previous value. So if it is not there, I'm finding the difference and storing the difference in the dictionary along with the index. So that's all. So let's run the sample test cases and see whether it is getting passed or not. Yes, all the 3 sample test cases are passed. Let's submit the full solution. Yes, it is accepted, and the entire solution is completed within 0 millisecond, which is highly efficient. And we can check the time and space complexity using this option. So I'm clicking here, and it will show you the time complexity, which is O of n, because for the checking operation in the dictionary, the time complexity will be O of 1. We can ignore that. So the time complexity will be O of n, which is for to check the each element in the array. So I hope the solution is clear to everyone, and if there is any doubt, if you find any difficulty in this question, please feel free to drop your doubts in the comment section. I will definitely help you. If you found this video is useful to you, please give me a thumbs up, and if you want to watch these kind of more videos in the future, please subscribe to our channel and don't forget to click the bell button. So in that way, you will never miss any video from our channel. So I hope you guys enjoyed this video. We'll see you in the next one. Until then, goodbye and take care.